What's up, guys? Back at it again. So let's do some examples. All right, it's getting a little late. Let's bang out some examples, then we're going to hit the hay. Okay, so at this point right now, I want you to take a peek at these exams. All right, sweet exams. Now, right now, I want you to pause the video and at least attempt this first one right here. And you can attempt the other ones as we go on. But right now, we're about to do the first one. So pause the video, do as much as you can yourself. Don't be afraid to get it completely wrong. It doesn't matter. In fact, you're going to learn a lot more if you get it wrong the first time around, because then you'll have the opportunity to see what you did wrong and you will remember those mistakes better and you won't make them in the future. So give it a shot right now. Pause the video. 3, 2, 1, go. All right, welcome back, guys. Thank you for all that hard work. Okay, now let's talk about it. All right, talk about moving. Dance Dance Revolution. I used to dance that all the time, that song. Oh, man, better days. All right, so let's attack this. We have 53 grams, and we want to find out how many milligrams we have. Okay, pretty straightforward, simple one. Let's get our units color-coded, though. Faux show. Grams blue, milligrams purple. Okay, so let's see here. How do we want to attack this? Okay, first of all, what do we know? Well, we know that we have 53 grams. That is what we are converting. Okay, we are converting 53 grams into something different. So what are we converting it to? Well, we're converting it to milligrams. So at some point down here, and this is probably too far, but we know we need to end up in milligrams. So what we know is we have 53 grams and we're trying to get to milligrams. In the meantime, what do we need to do? Well, we need to convert it. And it's not very difficult to go straight from grams to milligrams, so I think we're just going to have one conversion factor, make it nice and big, and then after that conversion, we should have equals something in milligrams. So you do need to memorize your metrics. You do need to know that. So you should know, if not by now, very soon, learn it right now if you need to, that there are 1,000 milligrams in every gram. Okay, so if we go down here and we look at milligrams down here, okay, we see that 10 to the negative third. This 10 to the negative third represents how much of a gram, how much of a meter, how much of a liter 1 milligram, milliliter, millimeter is. It's 0.001 meters. Okay, that means that there are 10 to the third or 1,000 milligrams in every gram, 1,000 milliliters in every liter, etc., etc. Okay? So when we're trying to write our conversion factor, which is our next step, we need to figure out what we know about the relationship between grams and milligrams. Just like up here, we had miles per gallon. Now we're talking about grams per milligram or milligrams per gram. So we know that there are 1,000 milligrams per every 1 gram. Okay, so that's the same thing as saying ten to the third milligrams, like we see down here, 10 to the negative third, right here, same as saying 10 to the third milligrams per gram. Now, we could also copy directly from this, and here what this is telling us is that there's 10 to the negative 3 milligrams per gram. So we could also say, I'm sorry, let me rephrase that, or just flip it around. There are 10 to the negative third grams per every milligram. So the other way to write this would be 10 to the negative third grams per every 1, milligram. Okay, both of these conversion factors that I just wrote are equally correct. You could use either one of them. It's essentially personal preference. I think that I like to, and most scientific people like to use this Just keep it positive, but this will give you the same answer, and this is the same thing. And if it helps you to memorize this chart with the -3 in mind, knowing that that means 10 to the -3 grams per milliliter, that's how much of a gram a milliliter makes up, and you want to write it that way, go for it. Go for it. They are both the same thing. They will both give you the same answer. For now, let's use the first one, and again, you could use either one. This doesn't make a difference. So, first of all, first thing we have to know is how are we setting this up? Because we could flip either one of these either way, and they would still mean the same thing. Okay, grams per milligram, milligrams per gram. It will be true either way. Okay, just like up here, you could flip miles and gallons. You could do gallons per mile or miles per gallon. Either way will be true. Either way will be true. So, what determines how we line this up? Well, if you want to get rid of something, you're holding something, you want to get rid of it, you got to drop it. You got to drop it like it's hot. Like that boyfriend who's bad for you, who always keeps dragging you down, just drop him like he's hot. All right, boy, bye. Okay, we're saying grams by. Grams by. We're dropping you like you're hot. We're dropping it down to the denominator. That's how it's going to eliminate itself, because you're going to, what this is essentially saying is you're having grams divided by grams, so grams are going to cancel. So grams is in the denominator, milligrams is in the numerator. So we got 10 to the 3rd milligrams up here, 1 down here. So we're multiplying 53 by 10 to the 3rd. Multiplying 53 by 1,000. So if you do that math, you get 53,000 milligrams. Now, one way to check yourself, or something you can do before you do the problem just to make sure that your answer is correct, or after you get it, is you need to think, should my answer be larger or smaller than what I started with? So we started in grams here, and then we canceled them. Now we're in milligrams. Okay, we started with 53 grams. Should that number grow or shrink when we go to milligrams? Well, let's take a peek here. So if we have some line that we're measuring, some distance. Now here we're not measuring distance, we're measuring mass, but the same logic applies. So if we have this, okay, and we're measuring it in grams, which is a larger unit, or whatever larger unit we're measuring it in. Let's say that there are this many units within this line for the larger unit we're measuring with. In this case, grams is the larger unit, we know that. So this is how many you get. And then you go and you measure it in a smaller unit, like milligrams. And instead of just being those few, now you have all these lines within here, because you're measuring with a smaller unit. These are smaller than the bigger ones. Okay, however, you're measuring the same thing. The line doesn't change that you're measuring, it's just your units. And there's less distance here, there's more of these ones than there are of these ones. So you're gonna have more here. You're gonna have a larger number here because you have more units of measure than you do here, where you just have 1, 2, and you have 1, 2, 3, 4, 5, 6, so on and so on. Because it's a smaller unit of measure over the same distance. And over here we have a smaller unit of measure for mass for the same amount of mass. So yes, it should be getting bigger. The numbers should be getting bigger when the units get smaller, because we're going to have a lot more milligrams in that sample than we have grams. So that's your correct answer, 53,000 milligrams. Okay, let's keep rolling. Okay, if this video is getting too long for you, I know you guys like to complain, then you can pause it. You can take a breather, meditate, have some happy time to yourself, and then come back. And while you have a pause, do this problem, all right? So if you're ready to go, pause the video, do the problem, give it a shot, keeping in mind what we just did, okay? Try this one. All right, hopefully you just tried it. We'll come back if you did. Okay, so this time we're going from hectometers. Let's make that, we'll do orange. All right, we didn't use that. Hectometers. We're going to centimeters. So that can be green. Going to centimeters. Okay, so I'll go a little faster this time. So our setup, we're converting 104 hectometers. So that's the first thing we'll write out. Okay, 104 hectometers. So we're going to have our conversion factor at least 1. Now, that's a sideways line. Me personally, if I'm going from something like hectometers to centimeters, which you can see here, so I'm starting up here with hecto, and I'm going down here to centi. I'm passing my unit. So in this case, I'm passing meters. I like to go stepwise. I like to go to meters and then to what I'm multiplying, what I'm trying to get to. So that means that I'm not just going to have one conversion factor. I'm going to have two, so that I can get to, in the end, centimeters over here. Okay? So what are my conversion factors going to be? And again, you can write it out either way, but this time I'm just going to do one. So if we go to hectometers, and this is again something you should know, hectometers, there are 100 hectometers, or there are 100 meters, just like there were 10 to the negative 3 meters per 1 millimeter. There are 10 to the second meters per hectometer. 100 meters to make a hectometer, because now we're dealing with units larger than a meter. Okay, so our conversion factor is going to be 100 meters per 1 hectometer. And I will rewrite that in color. That's the reason I spent so much money on this thing, is to make videos for you guys that are color-coded. What do we say for, we're doing grams in blue, so just to show you it's the same thing as units, I'll do meters in blue here. So we have 100 meters per 1 hectometer. We also have 10 to the second. You could put this as 10 to the second meters per hectometer, or you could put 10 to the negative second hectometers per 1 meter. But that doesn't really make that much sense. That's really confusing, especially when on the chart it already says 10 to the second meters. I'm just trying to make sure you guys see that everything here on this part of the graph is telling you how many meters there are in the unit you're using. So there's 10 to the negative 9th meters per 1 nanometer. That's how much of a meter it is. That's how you're measuring it. You're measuring all of these things in reference to the base unit. Meters, grams, whatever it may be. Okay, so we're going to use this for meters to hectometers. And then the second conversion factor is going to have to bring us from meters to centimeters. So for every 1 meter, you have, see down here, a meter, or a centimeter is 10 to the negative second meters. Okay, so we could write this as 10 to the negative 2 meters per 1 centimeter. That would be an acceptable way. 10 to the negative 2 meters per 1 centimeter. Just so you know that it is a correct way to do it, but that's not how I'm doing it here. Okay, so for every 1 meter, if it's 10 to the negative second meters per centimeter, that means you have to have 10 to the second centimeters per meter. And century is 100 years. You need 100 centimeters to make up 1 meter. Okay, so these are 2 conversion factors that we're going to use in one way or another to get to centimeters in the end. So if we're going from hectometers to meters, how are we going to cancel hectometers? Well, we drop it like it's hot, so we're actually going to leave the conversion factor the way we wrote it originally, with meters on top and hectometers on the bottom, because this is going to allow our hectometers to cancel. So we have 1 hectometer per 100 meters. So we're multiplying 104 by 100. That's going to allow us to cancel out hectometers. Now we're left with meters, trying to go to centimeters. So how are we going to set up the next one? Well, we want to get rid of meters because we want to end up with centimeters. And whatever you want to end up with has to go here. And whatever you're canceling from before has to go on the bottom. So we're setting it up like that. 100 centimeters per 1 meter. It's going to allow us to cancel meters. And that means that centimeters is going to be what carries to the final answer. So we have 104 times 100 times 100, or 100 as the kids say. So 104 times 100 times 100 equals 1,040,000 centimeters, which could be written, another important basic foundational skills to write in scientific notation. So we have 1, and you always have one whole number, then a decimal. It would never be 10 point something, it's 1.04, Okay, this is a significant figure because it's a captive zero. Remember that? Between two non-zero numbers, so we keep it. Times 10, what's it going to be? We're starting here. We go 1, 2, 3, 4, 5, 6, 10 to the 6th centimeters. Hi, John. Welcome to my video.
Who's it for?
My children.
Can I hear it right now? Us talking?
It's screen recording.
So they know we're talking right now.
They hear you. You're here.
You said hi to me, so you messed up your own video.
I didn't mess it up. They want to meet you. Say hi.
Hi, Jeff students.
No, I'm Mr. Simpson.
Oh, I mean, hi, Mr. Simpson students.
There you go.
Wait, so they can log on to this somehow?
It's on my YouTube channel, Simp Science. All right, so we wrote that in scientific notation, and that's our answer in centimeters. Let me think if there's anything I forgot. John distracted me. Okay, well, one thing to check is your number going to be getting bigger or smaller, and once again, we're going from a bigger unit to a smaller unit. So once again, we want to see our number get bigger because we're measuring with a much smaller unit. Hectometers are pretty big, almost as big as a kilometer. And we're going all the way down to something really small in centimeters. So yes, this makes sense that it's a number this large. Our exponent on the scientific notation is positive because we have a number larger than 1. If you remember that, exponent is positive with a number larger than 1, and you're moving to the right with when you kind of come out of the scientific notation, you go on to so when you're writing scientific notation, if you write out what you know you need to with significant figures, whole number, and then significant figures, I like to think, okay, what do I need to do to get back to my number up here? So I have to go 1, 2, 3, 4, 5, 6, and then fill these spaces in with zeros, and then I'm back to where I started. So anyway, that's the answer to this one. I don't know how we're doing on time. I know you guys freak out when something's taking too long, but that's okay. So I'll say one more thing about both of these, and then we can go, I'll stop the video. We'll go to the next problem in the next video. Okay, so another thing to think about is this down here that should look pretty similar to what you got in your notes way back when. So you can always just move the decimal, right? So if you have 53 grams like we had right here, and you know you're going to milligrams, you can always move the decimal. The decimal's right here. You can go 1, 2, 3, decimals here now, 1, 2, 3 zeros, 53,000. Okay, so we're starting at grams, which would be here. We're going to we're going to milli right here, 1, 2, 3. Okay, so you move your decimal 3 places and you're going to get the same result. So if you know that a milligram is 10 to the 3rd grams, then you know you can move your decimal 3 places to the right. 10 to the 3rd, positive 3, you move your decimal to the right. Same thing down here. So if you're going from hectometers to meters, and you know that 1 hectometer is 10 to the negative 2nd meters, so you know that back it up. I almost just stopped the whole video because I had to think for a second, but we're going to keep rolling. You know that 1 hectometer is 10 to the 2nd meters. 10 to the 2nd meters is 1 hectometer. So again, if you have 104, you're going to be moving a decimal 1, 2 places. Okay, and then a centimeter is 10 to the 2nd meters. So again, 1, 2. Okay, and then you get this number right here, 1,040,000. Okay, bless you, John.
Thank you, Jeff.
So you move your decimal however many places this tells you to. Okay, I always liked the decimal moving way better in high school because I thought it was easier, but the conversion factor way gives you a lot more structure, and it's cleaner and safer, I'd say, than trying to guess, especially when you're doing something like from hectometers to centimeters and you have to go so far. All right, so you can take a chance at this next one right now between videos, but I will do it in the next video.